Hey guys, how are you? I want to show you a few things about angle relationships. I just want to go over them with you and make sure you really understand what happens when you have two parallel lines cut by a transversal. So let me, how do I do this? Present. Okay, so angle relationships. So I made this slideshow for you. Here's a little cartoon about a right angle. Okay, so the angle relationships that I need you to know at this time, there are 5 of them. So these angle relationships appear when you have two parallel lines that are cut by a transversal. So in this picture here, line L and M are parallel, and then the transversal is line T, and it intersects the parallel lines, and then you see that 8 angles are formed. Okay, now these 8 angles create all these relationships. So when you have multiple angles, you can have complementary angles, supplementary angles, adjacent angles, corresponding angles, and vertical angles. Supplementary and complementary should be a review from last year. They deal with the angle measures. There are a few more angle relationships that you need to know, but I'm not going to go over them in this video. So let's start with the first one. So actually in this example right here, there are no complementary angles, and you'll see why. So complementary angles are when 2 or more angles, like this example on the left, add up to equal 90 degrees. Complementary angles equals 90 degrees. So this could be angle 1 and it's 25 degrees, and then you have angle 2 is 65 degrees, and 25 plus 65 is 90. So these are complementary. But this is the type of question that you will see. So you have line L, O, you have line O, N, and then you have O, M. Okay, that's how we name the lines, and we name the angles L, O, M. Is this angle in purple? So this angle measure, we don't actually know the degrees, but it's represented by the expression 2x plus 46. And the second angle measure is 3x minus 6. So in order to find the angle measures that add up to equal 90, we can write an equation. And we know since they're complementary, we know that angle 1, which is 2x plus 46, plus angle 2, which is 3x minus 6, has to equal 90 degrees. And then we just go back to the basics of solving equations. You would combine the like terms, so 2x plus 3x is 5x, and then 46 minus 6 is 40. You solve this two-step equation by subtracting 40 on both sides, and you're left with 5x equals 50, so you get x equals 10. Now that doesn't mean that this angle measure here is 10, because 10 and 10 is 20, and we need them to equal 90. So what you do is you take your x and you substitute it back in to each angle. So you have 2 times 10 plus 46 is, oh, you can't see it, which would be 66. So this purple angle is 66. Oh, there it is. And then you would do it for the green. 3 times 10 is 30, minus 6 is 24. So you have this little angle here is 24 degrees, and this little bit of a bigger one is 66, which when added together does indeed equal 90 degrees. The next angle relationship is supplementary. So supplementary is when 2 or more angles add up to equal 180. So complement 90, supplement 180. So in this simple example, we have angle A here, which is obtuse, and then we have angle B, which is acute, and A plus B has to equal 180 because look, this is a straight line. A straight line is 180 degrees. Now, if we do it with algebra involved in expressions, we have angle 1, which is 6x minus 10, angle 2, which is 4x plus 6, and angle 3, which is 7x plus 14. All 3 of these together are supplementary because they lie on a straight line, which is 180 degrees. So our equation would be simply angle 1, 6x minus 10, plus 4x plus 6, plus angle 3, which is 7x plus 14. Again, you know how to solve multi-step equations, so you're going to combine like terms. 6x plus 4x is 10x, plus 7 more x's is 17x. You have negative 10 plus 6 is negative 4, plus 14 is 10. So now we're going to subtract 10 from both sides, and we're left with 17x equals 170. So x equals 10. Again, that doesn't mean that each of these angles are 10, because how could they? They have to equal 180. So you need to use substitution to find each angle measure. So you're going to take this first one, 6x minus 10, and put a 10 here. 6 times 10 is 60, minus 10 is 50. So this angle here is 50 degrees. 4x plus 6, so 4 times 10 is 40 plus 6. This angle here is 46. Right? And you might say, well, this angle looks bigger than this angle. This particular example I found on Google, and it's not drawn to scale. And then the last one is 7x plus 14. So 7 times 10 plus 14, which is 84. And then you add all three of these, which I have over here, which is 50 plus 46 plus 84, will indeed give you the 180 degrees. Adjacent angles are, the word adjacent means next to, two angles that have a common side and a common vertex. So these two angles here, let me move my little face. Can I move this? Yes. So I have angle ABC, which is 22 degrees, and CBD, which is 39. They don't have to be supplementary. They don't have to be complementary. This really doesn't deal with the degree measures. This is just when two angles are right next to each other, we call them adjacent, right? If I was standing right next to Jayana, we would be adjacent to each other. And then here's another example. I have angle ABC and ABD and DBC, and they all have a common vertex and they share a common side, so they are adjacent. They're right next to each other. Why isn't it going to the next slide? Okay, so here we have corresponding angles. Corresponding angles are congruent. The word congruent, it's like the word equivalent. It means the same thing. So here, when I have my parallel lines cut by a transversal, let me go back to the first slide. Can I do that? See how we have 4 angles up top and then 4 angles down at the bottom? These 4 angles at the top are the same as these 4 angles down at the bottom. So corresponding angles would be angle 2 and angle 6. I don't know if this makes sense, but this is how I think of it. I think of it as 2 different lunch tables. You're at the same seat, just a different table. So if this is like the head of the table at table 1, the corresponding seat at a different table would be in the same spot. Does that make sense? Same spot, different table. So angle 4 corresponds to which angle? 8. Angle 1 corresponds to which angle? 5. Okay? Different tables. Like angle 1 and 3, are they corresponding? No. They're adjacent and they're supplementary because they lie on a straight line, but they are not corresponding. Corresponding is the same seat, different table. So 1 and 5 are corresponding. And then 3 corresponds to 7. And that means that they're equivalent. So whatever angle 3 is, so is angle 7. If angle 3 is 85 degrees, so is angle 7. If angle 3 is 5x plus 20, so is angle 7. So let's go back to the picture. So here's some more examples. So this 80 degrees corresponds to this 80 down here. They're congruent, they're equal. This 125 is the same as this one. Same seat, different table. Corresponding, corresponding. And they are congruent. Say congruent. Okay, I heard it. Okay, and the last angle relationship I want to show you today is vertical angles. So vertical angles are opposite of one another, and right here, this is the thing you need to remember. Vertical angles, like corresponding, are congruent. They are equal. So look at this example. This is 75 degrees. The one right across from it is also 75. What's the reason? They are vertical. This angle is 105. The vertical angle across, they're congruent, is also 105. It's kind of like they make V's together. V for vertical. Okay, so let's look at this one with these expressions. This angle here is x plus 16, and this angle here is 4x minus 5. So they are vertical angles, which means they are equal. So your equation is simply this equals this. So x plus 16 equals 4x minus 5. I minused x from both sides, and I added 5 from both sides. So you're left with 3x equals 21, so x equals 7. So if I plug it back in, you have 7 plus 16, and you have 4 times 7, which is 28 minus 5. So you'll get 23 for both of these. Let's go back to the beginning and talk about which angles here are vertical. They're across from each other. They make V's for vertical. So angle 2 is vertical to which angle? 3. Angle 1 is vertical to angle 4. Angle 6 is vertical to angle 7, and 5 is vertical to angle 8. And they're congruent. So whatever 6 is, so is 7. Whatever 2 is, so is 3. Okay, so it's a lot to remember. There's a lot of relationships going on, but they are all super important, and you're going to want to take some notes to differentiate between them all. And because you're going to have a quiz on this, you're going to need to know this. You're going to have to practice it. And when you get to geometry, this is all you're going to be doing. So text me, email me if you have any questions following this video. Thank you.